Let's end by looking at the limitations of the Bohr model. First of all, the model applies only to hydrogen-like atoms, that is, atoms with only one electron. Number two, the model is based on an assumption that accelerating charges do not emit electromagnetic radiation if they are in specific orbits. Number three, the model predicts the frequencies of the photons that are emitted when an electron changes orbits, but it doesn't predict their intensities. More work would now be done by Bohr and many other physicists to transition the explanation of atomic spectra into a more complete quantum theory. But before we go on, let's look at one more thing. The nucleus has a structure too. With all the incredible theories and experiments in the first 25 years of the 20th century, it's interesting that the neutron's existence was not proven until James Chadwick demonstrated its properties in 1932. Ernest Rutherford in 1920 proposed that a neutral particle with a mass on the order of the proton existed to account for the atomic mass measurements of atoms. Experiments were performed before Chadwick that actually found neutrons, but they were mistakenly believed to be gamma rays or even protons. So why do you think it took so long to discover neutrons? The neutron was hard to detect because there was no charge on it. It was impossible to detect by using electric or magnetic fields in the way that made the discovery of the electron possible. Chadwick found the electron by placing a small quantity of radioactive polonium in an evacuated chamber. There it decayed by emitting alpha particles, or helium nuclei, that then struck a beryllium target. Neutrons were emitted from this reaction, and they were found to have the correct mass and also a neutral charge. Neutrons are essential to us being able to combine more protons into a nucleus, but we'll find out more about that in the nuclear physics unit later on.